mathematical perspective, from mathematical side. So I put here left side operational availability, right? Product availability equals function of safety. Safety is always number one. Safety is always first. Failure rate, failure identification, failure recognition, failure troubleshooting, parts logistics, equipment tool, access open, repair replacement, servicing, testing, etc., etc., etc. Now, based on my experience, personally, I saw technical and non-technical approximately more than 200 items, technical plus non-technical, right? More than 200 items that can have impact on availability, product availability. I saw personally. Now you can ask question, okay, how are we gonna find out which item here is important for us? And the answer is very simple. You remember what we said in our previous presentation? We need to build factorial/timing model. Factorial model tells us, shows area for improvement. Now, what about from operational unavailability side, OUA? As we said, operational unavailability is function of maintainability, and maintainability is function time, resources, and maintainability coefficients. I put here lots of coefficients. Now you can ask, I think time and resources is more or less clear. So time is, as we said, 3-4 hours, resources 2 mechanics, 1 certified, 1 non-certified. What about the maintainability coefficients? And these maintainability coefficients, they are based on this list, based on the business model, based on the factorial/timing model. You know what? I calculated a lot of maintainability coefficients. I built a lot of maintainability nomograms and diagrams. Maintainability is a very interesting subject. There are a lot of books starting, so if you're interested actually, right, there are a lot of books starting from how to build the maintainability house up to how to use some good idea from nature to apply to your maintainability design. Okay? Anyway, let's go back to our today's discussion, today's subject. So, and let's simplify now these functions. So what we said that operational availability equals function. Number one, safety is always first, okay? Now I'm gonna use here Boolean algebra operator. So reliability conjunction with maintainability, cost, etc., etc., etc. Now I think safety, reliability, maintainability, and cost, more or less it is clear. What about the etc., etc., etc.? These points. The answer is these points are based on the list from this OA and OUA. Okay, based on your business model, based on your experience. As we said, technical availability, operational aircraft technical availability, operational availability is very complex subject. Same thing applies to the mathematical side. So, and then what I did actually, I took these 3 formulas from different sources. So they can use all this. There are definitely more formulas, but I think these 3 formulas are just describing perfectly the physical meaning of the airline operational technical availability. Okay, so formula or expression number 1. In numerator we have uptime, denominator we have uptime plus downtime. Number 2, in numerator we have product availability, denominator we have product availability plus product not availability, and number 3, numerator we have mean time to failure, denominator we have mean time to failure plus mean time to repair. Since we are talking about reliability, product reliability, I think number 3 is the closest one to our subject. So how we calculate MTTF? I'm going to explain how we calculate, very simple, on the simple level, how to calculate MTTF and MTTR. MTTF, let's say we have one aircraft and we have 2 AC generator removals. One was removed at 600 flight hours, another one was removed at 700 flight hours. What is MTTF? We are just taking average, and then MTTF is 650 flight hours. What about mean time to repair? Same story. Let's say one AC generator we replace, I don't know, 3 hours. We spend 3 hours, another 4 hours. What is MTTR? 3.5 hours. Let's move to the next slide and calculate operational/technical availability on system level. What we have here, we have 3 systems, 8824, 8825, and 8826. 8824 is electrical system, 8825 is equipment furnishing system, and 8826 is fire protection system. The blue lines means that system is available 100%. The red dots means that, red zone means that system is not available. We have issue, we have problem with LRU. Let's say for 8824 we have problem with the left AC generator. 8825 we have problem with cargo compartment floor panel. And 8826 we have issue with the lavatory smoke detection system. Oh, excuse me. I would like to mention also that we can see sometimes, some manufacturers, sometimes they put CFP under 8850. Okay? Oh, and then here is the time scale. Okay? Now, also we have here, I took from previous slide, operational availability function. So operational availability function, or operational availability equals function of safety, reliability, and maintainability. Today, from maintainability side, we're gonna use average time to spend to fix one failure. Unfortunately, today we are not gonna calculate cost, because cost is another very huge, very nice and very huge subject. Probably I will create later the presentation, especially for aircraft economics, okay? But today let's focus on operational availability. Now let's transform this function to the usable format. Operational availability equals 1 minus operational unavailability multiply 100%. Let's check this formula using ideal case. Operational unavailability, using ideal case, operational unavailability equals 0. Let's insert this 0 here. 1 minus 0 is 1. 1 multiplied 100%, it is 100%. Okay? How we are calculating operational unavailability? It is very simple. Operational unavailability is sum of the next component. In numerator we have reliability multiply maintainability. Denominator we have time. In our case today we're gonna use 24 hours. In your case, based on your business model / factorial model, you can use 1000 flight hours, 1000 flight cycles, or even 10 years. Okay? How many times we need to summarize these components? From 0 to n. What is the n? Today, from reliability side, we're gonna use n is number of failures, number of removals, LRU removals. Okay, let's go to calculate our operational availability for each system. I already did this calculation, and here is a table. The column number 1 is failure identification number. RN in this table means total failures. MT is average time spent to fix the problem. OUA, we're gonna use this formula. And operational availability, as we said, we're gonna calculate per system. Here's the systems. Per aircraft, this is the aircraft, okay. Here's pilot, here's yoke, okay. And 24 hours. I'm going to identify this time period. This is very important. Let's say this is here 24 hours. Okay. What we have? For 8824, this per given 24 hours, per given time period, we have 1 dot. So it is recorded here, 1 problem. For 8825, we have also 1 problem. For 8826, we have also 1 problem. So we have triple ones, okay? Now, question for you, what do you think? Can we say based on this reliability information, this reliability data, can we expect that OA also is going to be similar for all these 3 systems? Answer is yes and no. Why yes and no? Let me explain. Let's go to the formula. So as we can see, we have 2 variables. Variable number 1, it is reliability, and variable number 2, it is time. So reliability, we said we have triple ones here, so 1, 1, 1. What about time? And time, actually, from time perspective, we have actually 2 options. Excuse me, 2.5 options, okay? Let me start from 0.5, okay, option. So if we open official document from manufacturer, which is called the maintenance planning document, let's say that we can see that, let's say, again, I don't know exactly, but let's say the time to fix AC generator and CFP is equal, is the same. Okay? This is from manufacturer document, official number. Right? Again, I'm just guessing. I don't know exactly what is the numbers. But if you remember, from operational side, we have a little bit different story. And if you remember what we said during our previous presentation, when we built the factorial model, we said this business has 2 sides. I'm talking about technical sides. So on side number 1, we have dispatch-oriented environment, and side number 2, we have schedule maintenance-oriented environment, which is time. Option 2 and option 1. Now, we can see that TSM, so time from schedule maintenance, can equals to time MPD, or time manufactured. Yeah, there is a chance that it can be similar. But what about dispatch-oriented environment? And then from this